All right. So there's a number of voters, 14, 10, 8, 4, 1. They gave their first choice, second choice, third choice, so on. And there are 4 candidates. That's probably the main thing is you have to figure out how many candidates there are. I think you guys use like, Hamilton, whoever. But A, B, C, and D. All right. And to start here, you compare A and like you just say, okay, we're just gonna start comparing like A and B, for example.
Okay.
And so for example, when we just compare A and B, you look at the first column here and you're like, who wins? Who wins between A and B? Well, A is above B. So A wins, A gets 14. And then you do the same thing in the second column. Second column, B wins, B is above A, so that's 10. And then in the third column, you have B above A, so that's 8. And then B is above A, so that makes plus 4. And then B is above A, so they win. They are the big winner. So B gets a point. So you have kind of this like point system that you're keeping track of. And then, everything we just did, you throw away, and now you compare like A versus C. Okay, so this time on the first column, A is above C, so you get 14. And then in the second column, C is above A, so they get 10. In the third column, C is above A, so they get 8. And then in the fourth column, C again wins. So the last one doesn't even matter. Like once you get an insurmountable lead, it doesn't really even matter. But if you wanted to, they get the 1. So C gets a point. And then you might try A versus D. All right. So A versus D, same thing here. Looks like A wins the first one, but D wins the second because they're above A. D wins the third. You're kind of seeing a trend here. B wins the fourth. They have an insurmountable lead. And for good measure, they win the last. Okay. All right, so those are all the A comparisons, A versus B, C, and D. Now you go to B, we compare B with C and C with D. So I'm just going to reset this here. We're now going to compare B versus C. So you look in column 1. Okay, B is above C, so they get the 14. C is above B, so C gets the 10. C is above B, so they get the 8. B is above C, so they get the 4. So notice they're tied heading into the last one there. And so you say, okay, well, what's the difference? B and C. Well, C wins. There's one above there. So we had A, B, C, and D. So they did have one each. Now C has another one. Is it clear so far?
Oh, yes.
Okay, very good. And then B versus D. It's okay if you want to stay muted. I kind of rambled on there for a while about this. And so B versus D. First column again, looks like B wins. They're above B. And then second column, B wins 10. So that is an insurmountable lead. Like I know when we did it before, we kept going, but you don't have to. You can say, oh, I mean, there's no way for D to get enough votes. And in some ways, that's how elections are tallied, right or wrong. That's what they do. The last one here is to do C and D. Notice like you don't have to do B versus A because we already did that the first time around. And so C versus D, same thing. So C is above D, that's 14. Second column, C is above D. It's another insurmountable lead. So C wins. C wins. All right. And so you tally them up, you're like, okay, C got all the C won more than the others. They're the victor. Would you like to try one that's much shorter on your own here?
Yes, please.
Okay. All right, give that a try, please.
Do they all have one vote for, or do they all win one time?
I didn't check. So I can quickly do this though. A versus B. Let's see here. A. Okay, so A, did you have that A wins the first one?
Yes.
Okay. And then A versus C. C win, did you get C wins on that one?
Yes.
And then you probably got B winning in the next one. Let's take a look here. Versus C. Yes, B wins. They each get a point. If they tie, which is possible, they get 0.5 points for a tie.
Hmm.
I don't know. I'm just grabbing this out of a lecture from University of Alabama, Birmingham. So I don't know. Is that okay? I mean, do you understand it though? I mean, you did that really well.
Yeah.
Okay. Looking for a good board account method problem here. I don't know why I'm struggling so much with this one. Okay, I think maybe I've got it here. Maybe I'll save that one. It's too complicated. Why did they do that? Okay. I've got a board account problem up. I don't like that one. Okay, this is, I guess, is the best we've got. So here is here's a board account election problem. All right, So notice that there are A, B, C, D, four groups, four candidates again. I noticed that A finished first, fourth, and fourth again. But this time you, and this is for board account, I should specify that first. So you give point totals. So for example here, fourth is 1, 2, 3, and 4. So A, for example, they got 14 times 4 for this first position, plus 10 votes times 1 for the last position, plus 8 votes times 1, plus 4 votes times 1, plus 1 and 1. So you have to label like the point, I don't know, it's like a weighting kind of thing, times this based on where it's at. Is that okay?
Yeah.
What is this? 56, 66, 74, 78, 79. This looks super familiar, like we did this once for. Okay, same thing for now we do B. So B, I think it's helpful to circle them.
Yeah.
Numbers again. So B is 14 times 3 plus 10 times 3 plus 8 times 2 plus 4 times 4 plus 1 times 2. So we got 42, 72 plus 1688 plus 16, 104, maybe 106 for that.
Okay.
You kind of see how I'm doing that here?
Yeah.
Okay, I'm gonna have you try C next. Let's circle them for you though. So you got C, 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 and C. 1, 2, 3, 4. Gonna go ahead and try that for me, please.
You can give all this back at the school. There's like a whole team behind you to your left as well. You have to click. I'll ping them for you. Thank you.
<clears throat> 114.
No, I got 118. Maybe I made a mistake here. So I did 14 times 3 plus 10 times 4 plus 8 times 3 plus 4 times 2 plus 1 times 4. Does that match up with what you have?
I had
Oh, this
14
is
times
2.
2.
2. There's the difference. Okay, any other differences?
I don't think so. The rest looks the same.
What do you have?
That was my fault. Yeah, so 104. So we can kind of look right now and see where we're at. We can say, okay, B is first place, C is second place, and then A is third place. And we'll do it one more time for the last one there. Did I do it for, yeah, we're gonna do it for D now. Okay, so we're gonna do it for D, yet another color here. Let's go boom, 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 boom. Okay, could you give that a try, please? Let me label these as well. 1, 2, 3, and 4.
You still there? That would be good cancer.
$77.
I'm just way off. So I got 14 times 1, 10 times 2, 8 times 4, 4 times 3, 1 times 3.
You gotta run. You gotta run. Do not engage these people, bro.
I think that's 81.
Yeah.
So, I mean, it's not really difficult, right? It's just easy to make mistakes. It doesn't actually impact the outcome because I think B is the winner there. Although I'm certain maybe we did not, maybe we made an error somewhere, but you kind of get the idea, the hang of that for this.
Yes.
Okay. Let me see if I can find one more for us to try like that. Let's go back up and do a board account on the one I gave you, which I can't find right here. Okay, let's do a board account on this one right here. Go ahead and give that a try, please.
Hail Mary, quick.
For A, I got 19, B, I got 16, and C, I got 19.
Same here. So this is a scenario where there's a tie And I think we did like cover that. We said, okay, what happens? And sometimes the methods don't give you a certain conclusion. And that would be the case here. All right,
Okay.
does that feel like it's sufficient for
I tried to use something that's covered, use the water,
Yeah, I think so.
yeah.
like standing there's.
Okay, so the one thing we didn't cover that I did want to just write down real quick in your notes here is this was sort of it's real quick. So how to increase or decrease confidence interval. There's really two ways. To increase the confidence interval, you increase C. That's the, like 0.98%.
Mhm.
If you want to decrease the confidence interval, you decrease C. Now I wrote earlier that C is equal to 1 minus alpha. So there's a relationship to that, but I don't think you guys talk too much about that. The other thing you can do to, well, the other thing that causes the confidence interval to increase is sample size N. Okay.
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 You may just have to do all the fucking work.
Now, when N increases, I don't know if you remember this, when N increases, what happens is, and this is the one that's kind of inverse, you actually want sample size to go down to increase the confidence interval. These are the ones that are inverse. And so if you want your confidence interval to get narrower, you increase the sample size.
Okay.
But this is the, I mean, I think you're going to question like this, multiple choice or something, is that goes up, or, what happens when you increase C, or what happens as you decrease N? That's kind of the thing here.
Okay.
That you might be looking for. All right. So the last stuff here is existence of Euler paths and Euler circuits. Euler circuits. Yeah, this is something that doesn't get covered very often. And so here, this is kind of that main overarching thing. An Euler path is a path that goes through every edge of a graph exactly once. The circuit is the same thing, but it has to begin and end at the same vertex.
Mhm.
And so there's a theorem that's kind of summarized. Like I would definitely put this on my reference sheet. They talk about the number of odd vertices, and then whether that creates an Euler path, Euler circuit, and then the other ones here where no such one can exist. So I mean, this kind of it's like I mean, I guess we can look at some examples here, but the they're just hard to show. So here's an Euler path. Start with this. So the path they give you, and there may be more than one, but they're trying to show you, okay, you start at B, do that, try and follow the series. You start at B and you go around, or I'm sorry, you go around to there, and then you go to A, go to D, go to C, back there. But notice you don't finish where you start.
Mm-hmm.
You don't finish where you start. You start at B, but you end at C. But it's a path. You hit every edge exactly once.
Okay.
So that means it's either a 0 or a 2. Odd vertices.
Okay.
You remember talking about that at all?
Yeah.
So A, B, C, D, and E. A has 2 coming out, so I believe that's an even. B has, I don't remember how to do loops here, but I believe it's also even because the, well, I take it back. 1, 2, 3, 4, 5. I don't know about B. We'll come back to that. A little nuanced part of that. C has 3, so that's odd. D, 1, 2, 3, 4, even. E has 2 coming out of it, so it's even. So yeah, I'm going to say that I'm going to say that B has 1, 2, 3, 4, 5 odd. There's 2 odds. That's why it's an Euler path, because it's got 2 odd vertices.
Okay.
The next one I'll show you is a circuit. Oh, and your last test, did you end up having to draw them, or did you have to just decide whether it was a path or a circuit? Or none?
They were given to us, but we just had to like trace it and determine which one it was.
Okay. And I assume your final will be gotta be really similar to that, right? Can't be,
Yeah.
at least we hope. Okay. So it's nice when they tell you the path, which is what they're doing here.
Mm-hmm.
They're telling you to start at C. We will do that. Try a different thing this time. So C to D, to E to B, all the way around and back. So that worked out great. Now we can do the same thing, labeling A, B, C, D, and E. A has 2, it's obviously even. B has the right, the left, this one, and this one, that's 4, that's even. C has 2. D has 1, 2, 3, 4, and E has 2. So notice it has 0 odd vertices, I guess is what we would say. This is 0 odd vertices.
Mm-hmm.
If we go back here, it is an Euler path and it's an Euler circuit.
Okay.
So let me see if I can find any more sort of simpler ones so that they really need to give you the path. Like, I guess if you but we can also just, okay, so let me backtrack here. The programmatic way to do this is to look at each of them and just count the number of paths out. So A has 3 out. That's 1 odd. B has 1, 2, 3, 4, 5. That's 2 odds. That's not good. C has 1, 2, 3, 4. That's okay. D has 3. So notice we have 1, 2, 3 odds.
Mm-hmm.
And if we go back to our table, I know we're scrolling. If it has 1, 3, or 5 odd vertices, it's not possible. So we're not looking pretty good.
Yeah.
Let's keep, so E is got 3 coming out, so that's 4 odd. So 4 odd, you go back to your chart here and you're like, okay, it's not an Euler path, it's not an Euler circuit.
Okay.
Let's look at another one here. So for this one, I'd like you to make the table and count the number of paths, out of it. So put this right here.
Yes. Yeah, fucking see this guy.
How do you know where to start
Okay,
for
no,
this?
no, we don't, we're not trying to draw this. We're just trying to label the number of
Oh,
vertices.
okay. Okay.
They're going to each vertice and figure out. Because if it is a path, then you go and figure it out. But if it's not, you don't even try.
Okay. It only has one odd vertex.
Go ahead, give me the numbers for each of these, just to confirm here. What'd you get for A?
I said 4.
4, and B
4,
and C.
3. Or sorry, 4.
Good. D.
Um, D, I got 2.
Okay, and E.
4.
F
4.
and G.
4.
Yes, I don't have. There's 0. There's 0 odd vertices, which means that it's both a path and a circuit. Now, finding it, that's a hard thing to do. I mean, that you could kind of bang your head, just being frustrated on this, but we know that it is one. I don't know if you got anything that's complicated on your test, but that would be something to kind of look back on. Maybe, maybe a friend got a different version of the test.
Mm-hmm.
Okay. Like I feel like that covers that stuff, but you tell me if you want me to find more examples. We can then move to Hamilton methods, number of brute forced, find nearest neighbor. I don't know. That seems new. I don't know if we did any of that before, but Any idea what this is referring to?
Yeah, there was a worksheet that we did on it.
Any chance you can send it over real quick?
Yeah.
Calculation.
I did find an example that might be something that you guys were doing.
Okay.
You're still welcome to send that over. So the problem here, it says a garbage truck must pick up garbage at 4 different dump sites, A, B, C, and D, as shown, starting and ending at A. So he's got to start at A, okay? And we could do the whole thing we did before, where we'd say, okay, A's got 3, B's got 3, C's got 3, and D's got 3. That's not good. Well, the problem here is there's not like an optimal path, because you're gonna rerun over one of these legs or sides.
Mm-hmm.
Because there's 4 odd vertices, that's terrible. Like that, so there's and this is your nearest neighbor, by the way. That's the nearest neighbor. So it says to try each vertex at the starting point and then choose the best answer. But since it has to start at A, well, I take that back. If you start at A, you have to decide which path you're going down. And then to do that, you choose the minimal weight. Okay, so for example, if you start at A, you have a choice. You can either go down to C, down to D, or down to B. But you would choose B because it's the least.
Mm-hmm.
Does that make sense? Like,
Yeah.
and then from B, you got to choose, okay, well, which way am I going to go? Am I going to go B or C? And it looks like you'll go D. So now you're here at D. And then you're choosing to go to C, because I think because you've already been to A, you'd say, okay, well, I don't want to go back there. C, and then you go back to A because you can get back there. But why wouldn't you go C that way? I'm just wondering why you wouldn't just go 3 and then 4 to get back. Did you done something over? Maybe. Wow.
Yeah.
So the other, that's your starting A. So if you started at B, when you're at B here, you're like, okay, either you're going up to A, to B, or to C. You choose to go to D first because that's the least. And then from D though, you're either going up to A or to C. You'd choose to go up to A. Now from A, you've already been to B, so that's why I don't think you would go back to there. So you go to C. But then you need to get back to B, so you would take that route there. And then what you do in each of these situations is you start adding up. So this one, A to B is 4, B to D is 2, B to C is 10, C to A is 14. And you calculate, okay, well, that was 30. B to D is 2. D to A is 6. A to C is 14. C to B is 3. So 17. So that's 25. And then you could repeat this for C. So starting at C, our choice is made to go to B. We look at 14, 10, and 3, and we say, well, let's go to B. So C to B. From B, we would go to D, because that's the shortest one. From D, we've already at C, so we might as well go up to A. And then we're at A, and we want to get back to where we started, which is C. So we go back there to C, that's 14, and that's also 25.
Okay.
And then you could even start in the middle, which same situation. You start at D, and you got to say, okay, am I going up to A, down there, or there? We're going to go to B first. So D to B is 2. And then from B, you're either going up to A or over to C. We'll go to C because that's a 3. Now that you're at C, you don't go back to D because you've already been there. So you go up to A for sure, but that's a 14 weight. And then A, you've been to all of them, you go back to D. That's 6. And that's also 25.
Okay.
Now, the problem is that that's actually not the best solution. I think is the whole point of this is like, these all seem good, but there's actually a better one. So let me show you that real quick. Is it helping?
Yeah.
The nearest neighbor stuff. So the best path is to go A to B to C to D to A. Could you calculate that for us, please?
23.
23. And notice that's way better than all the other ones. So
Yeah.
why is that? Well, when you start at A and go down to B, okay, normally we would just go back to D, but the 3 really isn't that much worse than going to like it's not that bad. And well, notice what we're trying to actually avoid is this 14. That's a big one. It's a big heavyweight. So when you get to C, you can get back there, then you get back to A.
Okay.
So it's the brute force is like when you try all the possibilities. You sometimes hear that when you're breaking passwords,
Mhm.
and that is okay. So the not sure what else. Let me see if I can find any other quick examples. I keep seeing this. I took classes in this, but I don't really enjoy this stuff. So that's why it's really awkward. But I keep seeing this formulas for distinct Hamilton circuits down here, n-1 factorial. And I keep seeing this number of edges formula here. So that might be good to put down. I could just see a scenario where you are given like n and you have to calculate this, know that it's n minus 1 factorial. Do you remember where factorial is on your
Um,
calculator?
is it math and then probability and then number 4?
Yes.
Okay.
Okay, good. Let's look at your list one more time here, see if there's anything else we can quickly sort of talk about. The one thing I didn't talk about today, because I have no idea what this is referring to, it says use correct stem. I have no idea what that means. Is that any idea what that's referring to?
I have no idea what that means.
Stem and leaf plots, but that's pretty far back in the course. The other thing here that and I'm really bad at this because I don't these conditions. There's conditions for all these stuff that you're doing, and we kind of addressed it, like use a t-test when sigma is unknown, and
Mhm.
use a z-test when sigma is known. Every test, every confidence interval has a set of assumptions. I don't, you'd have to look at your old tests to know how that was brought up. Like, were you ever asked to state the conditions? Were you ever asked to write them down? Did you have to verify conditions? There's one for like proportions where n times p has to be greater than or equal to 10. But that's kind of in the weeds. I mean, that's really specific stuff. So I don't know. You maybe look at one of those tests. Maybe ask about STEM from someone else that might
Okay.
know what that is. But all right, so we're going to go ahead and stop here.